Hello everyone, I am Vinayak Patil from Sir College of Engineering, studying in Electronics and Telecommunication Engineering. Today we will be looking into transition from IPv4 to IPv6, NAT64 and other techniques. So, introduction to IP addressing. So, what is IP address? IP address is a unique identifier for devices on a network. IPv4 uses 32-bit addresses allowing 4.3 billion addresses, while IPv6 uses 128-bit addresses offering a vast number of addresses far exceeding the demands of the modern internet. IPv4 encryption led to the need of IPv6 as the number of connected devices continues to grow. So we will be looking into IPv6. IPv6, the future of networking. IPv6 provides more address space, security, and mobility support. IPv6 is designed for future-proofing, catering to new technologies like IoT and mobile networks. Challenges for adoption include upgrading infrastructure and legacy IPv4 support. Many websites and servers still run on the IPv4. Necessity transition techniques for IPv6 clients to access IPv4 only services. IPv6 only clients face challenges connecting to IPv4 only services. Transition techniques help bridge this communication gap between IPv4 and IPv6 systems. Overview of transition techniques. So, in transition techniques, there are three methods, that is dual stack, tunneling, and translation. So, in dual stack, devices support both IPv4 and IPv6, allowing for backward compatibility. So, this technique is used in the very many mobile phones. And second one is tunneling. IPv6 packets are encapsulated within IPv4 to enable communication across IPv4 networks. And third one is translation. IPv4 addresses are translated into IPv4 addresses. Sorry, translation. IPv6 addresses are translated into IPv4 addresses in real time, enabling IPv6 only clients to access IPv4 services. So we will see one by one. First one is dual stack. Dual stack allows devices to use both IPv4 and IPv6 protocols. It ensures compatibility with both IPv4 and IPv6 networks, but requires full support across devices, networks, and services. Second one is tunneling. Tunneling techniques like 64, Teredo, and ICTAP encapsulate IPv6 packets inside IPv4 packets to facilitate IPv6 communication across IPv4 networks. While effective tunneling has limitations with firewalls, routing, and network overhead. And our main focus will be on translation techniques. Translation techniques like NAT64 and DS Lite enable IPv6 only clients to access IPv4 services by translating between IPv6 and IPv4 addresses. NAT64 uses DNS64 to create fake IPv6 address for IPv4 servers, allowing communication between IPv6 clients and IPv4 servers. NAT64. DNS64 is used to generate synthetic IPv6 addresses for IPv4 servers. NAT64 translates IPv6 packets to IPv4 packets and vice versa, enabling IPv6 only clients to access IPv4 services. So this part we will be looking in next slides in detail, and in that I will explain with flowchart that how actual communication happens. So NAT64 is useful for organizations transitioning to IPv6 while still needing to access IPv4 only services. So NAT64 architecture diagram. NAT64 architecture shows how IPv6 clients interact with IPv4 servers using translation techniques and DNS64. So we can see the architecture diagram. Now we will discuss the NAT64 architecture diagram with proper explanation. So here we can see this is our PC, and which I will take it as a pointer. See, first we will see what is NAT64. It allows devices that have only IP6, IPv6 to access IPv4 only websites or servers. Very useful in networks like mobile networks, cloud-based infrastructure, universities or ISPs switching to IPv6. So from this slide, we will look into how it works actually. So this is the IPv6 only device client wants to connect to the website, that is www.example.com. Okay, so here DNS64 server comes into play. So this is the IPv6 only device. It sends the DNS request to DNS64 server. So we can see here this arrow, and then DNS it doesn't in DNS64 it doesn't find an IPv6 record. So it takes a IPv4 record and creates a fake IPv6 address using a prefix uh, like that 64. Okay, 64 FF9B like. So then this is the second step, and then uh, third step is IPv6 packet is formed and sent to NAT64. NAT64. Okay, so this will take help from that IPv4 DNS server, and this will give his IPv4, and after that this is sent to again DNS64 server. Okay, so then NAT64 receives it, and here NAT64 receives it and removes the IPv6 headers and adds IPv4 headers, and then forwards the converted packet to the IPv4 server. So this one, the IPv4 server processes the request and replies with IPv4 response. NAT64 does reverse translation and sends the IPv4 reply to the client. So here the client is happy. It thinks it is connected to a normal IPv6 website. So this is the basic architecture diagram. Okay. So now we will see other translation techniques. So these mentioned techniques are the other translation techniques which are used. So what is the conclusion for today's teaching? IPv6 adoption is crucial for future networking and continued growth. Transition techniques like NAT64, dual stack, and tunneling are vital in short term to bridge the gap during the migration phase.